This is one of our brand new Hotpoint PTACs. It's got a brand new fresh look, an updated and improved user interface, and other great features. But the reason I've got it here is so I can show you how to make a 265 volt permanent connection to meet NEC code. The first thing we're going to do is remove the indoor grill by pulling out slightly on each side and then lifting it off the PTAC. That'll give us access to the two screws that secure our user interface. And we'll remove those. These are Phillips screws. I'm just going to place my screws down here in the base pan. With this removed, I'm just going to lay it over the top here to get it out of the way. Now I've got 5 screws to remove, so I can remove this main board cover. And I'll set my cover aside. With the main board cover removed, that's going to give us access to our terminal block here where we're going to make our connections with our wire. We've got a 1/2 inch knockout here where we'll make our connection, put our connector through there, and then we've got line, neutral, and ground connections to make. The National Electrical Code, or NEC, requires that 265 volt PTAC units be permanently connected. Using a permanent connection method for powering 265 volt units offers substantial liability benefits. It reduces the risk of electrical hazards, ensures compliance with safety regulations, enhances safety for guests and staff. By prioritizing these safety measures, hospitality establishments can protect themselves from potential liabilities and create a safer environment for everyone. The tools and supplies that we're going to need for this project are some flexible 1/2 inch electrical conduit. I've got a 30 amp circuit, so I'm using 10 gauge wire, 2 90-degree flexible conduit connectors with a 1/2 inch throat, a junction box cover plate with a 1/2 inch knockout. I'll be using 3 crimped on terminals to make the connection at the terminal block on the PTAC, and I've got some crimpers, side cutters, a Phillips screwdriver, a small square drive for my electrical connectors, wire cutters and strippers, and some needle nose. Now what I've got set up for demonstration purposes is a 2-gang electrical junction box, and we'll be making our connection here. And so instead of a receptacle, which does not meet NEC code for 265 volt products, we're going to be using our 10 gauge wire and our flexible conduit. There's not a receptacle here. If you've got a receptacle, just simply remove that receptacle, and then I'll show you how to make the connections. In preparation to measure my length of my flexible electrical conduit, that's going to be the most difficult thing to do, is measure the length for that, determine that. Once we get that set, the rest will go pretty darn easy. So I've got my junction box cover plate here, and I'm going to take my connector and I'm going to go ahead and connect this to my cover plate. Then I'm going to take a Phillips screwdriver and just kind of tighten that in place. And this is going to be so we can determine a length for our flexible conduit. To prep this side, the junction box for a PTAC, I'm just going to go ahead and take one of my connectors and I'm going to secure it to the flexible conduit. That way I'll have a good solid point to start measuring my conduit. So I'll just tighten up these screws on the connector to hold the conduit into the connector. And I'm going to need to make sure it's pretty flexible in this area here so it can make the twist and turn. So I'm just going to kind of massage it here to give it just a little bit more flexibility in that area. Don't do it too hard or you'll break the conduit, and then you'll just have to cut it off and start again. With that, I'll remove my lock nut, and then I'll put this connector into place. I'm going to want to point it out in this direction here, and then I'm just going to take my conduit and then measure over and get an approximate length. So I've got it up here on my junction box, and I can see I need to cut it in this area right here. Well, I'm going to go ahead and just put pressure on this until it opens that, and then I can pull it apart just a bit. Now I can take my side cutters and I can make a good cut across that conduit. Now what I'm going to do is just make sure I don't have any sharp edges or anything that could damage the wire. To make it easier to feed my wiring through the flexible conduit and make this 90-degree turn here, I'm going to go ahead and remove this and then separate this. Now I can remove my conduit. And feed my wire through the conduit. And then feed those wires right up in through that connector. While I've got it here, I'm just going to go ahead and see how much wire I'm going to need to go from this connector up to my terminals. That's probably a little bit long. I'm going to pull them about right there and hold the wires. Now I'll take my conduit and put it back into that connector and then tighten it down. And that's got everything good and tight there. Now I'm just going to make one more check here. Go ahead and put my wiring through the knockout. And then put my lock ring on and tighten it down. And I think that's going to be just right. But while I've got some slack here and I've still got some leeway to move the wire if I need to, I'm going to go ahead and strip these and then put on my terminals for these connections. Now I can take my crimpers and I can put these terminals on to make a good connection. That one on there, make sure the wire is all the way through. Take my crimpers and give them a good crimp. There's one. And three. I'm going to go ahead and make sure my screws are backed out enough where I can get these connectors back behind the screws. That ought to be good. Now green is always going to be ground. That's not a problem. So we'll put the green wire in our ground terminal here. I'm going to pull it out the other end. Got a little too much there. Make sure I get it behind that connector, and then I'll go ahead and tighten this one up. Make sure that's good and locked in. Now red and black, you just got to pick one or the other. Which one's going to be line and which one's going to be neutral. I'm going to go ahead and make the black wire my line wire, which will carry the 265 volts. Make sure to get that up in there good and tighten it up. Now I'll get the last one, which the red is going to be our neutral. So get that up in to place and then secure that screw. So we are all good. All of our terminals are good and locked in there. We've got this flexible to where it's going to make that curve nicely and fit within our indoor grill. Now we can start working on this end here. Since I've got this end done, I'm just going to pull this cable over here and just make sure I've got enough wire to go inside my junction box and make the connection inside there. So I'll cut these wires at that length there, and I'm going to go ahead and remove this cover here. And make sure this is all loose here. And I'll feed my wires through this connector here. Just give them a little bit of a curve to make that 90-degree turn there. And feed the wires through. And I'll go ahead and tighten up this connector here. And with that good and tight, I can go ahead and strip these wires and make my connection in my junction box here. just happen to have red, black, and green on this side too, but you just want to make sure that you get L1, neutral, and ground connected to the proper wires. And there's 3. So, this is where my junction box is at. This is just for demonstration purposes, but yours could be maybe on the right side, the left side, or somewhere in between here. But it should be the same process to get this done. Now, before I put my junction box cover on, I'm just going to give this lock nut a tighten here to make sure it's good and secure. And it is. Cable's good. Just going to dress and tuck these wires in, and then attach my cover plate. Got everything done as far as the connection between the junction box and the PTAC. Now we just got to put the PTAC back together and we're ready to roll. So before I go back on with the main board cover, I am going to explain what these 2 connectors are for. If you're going to use a wall thermostat to control the PTAC instead of the user controls that come with it, you need to purchase a thermostat connection kit, and that's what these 2 points are for. This is a 24-volt power supply to power the thermostat, and then this one's for the signals that come from your thermostat and communicate with the PTAC. Since we're going to be using the onboard controls, there's nothing I need to do with that. So I'm going to take my main board cover and put it back in place. And I'm going to start with the screw that secures the bottom of the junction box, which is where my connector is here. And I did tighten up this lock nut on this connector, make sure it was secure as well. And get my 2 screws for my user interface. There is a locator tab here that goes into a position on this over here. So make sure you get that in place, and then put the 2 screws on. There we go. With that, move my tools a bit. Now we can replace the cover on the PTAC. Just make sure the sides go on. Just pick up just a little bit and then push down on each side if it didn't go in. So like this side didn't go in, I just lift up a little bit and then push straight down. And that's it. We've got a safe installation that meets National Electrical Code.